At some point, we're going to try to make a foldable because yesterday we learned 3 things. There were 3 different theorems. Today we're going to learn 3 different formulas. And then, I don't know, several days from now we're going to learn another 3 formulas. And it's a lot to have you try to memorize. So we're going to try to put together a foldable so you can get the formulas written down and maybe some examples. Okay, so we've got 3 formulas that we're going to learn today. This first picture is a picture of an inscribed angle. We briefly talked about what that was yesterday. An inscribed angle has its vertex on the circle. So if the vertex of the angle is on the circle, that's called an inscribed angle, and this is the formula for it. So if it's an inscribed angle, if the vertex is on the circle, then this angle here will be half of the intercepted arc, and the intercepted arc is arc AB. So angle X will be half the measure of whatever arc AB is. Okay, and we're going to call this on. This one, do you see how the vertex is on the circle? So we're going to call this one on 2. Today we're going to be talking about on, inside, outside. So if the vertex is on the circle, we're always going to use this formula, half of the arc, half of the arc. As long as the vertex is on the circle, we'll use half of the arc. Now this has a tangent. Remember, a tangent only intersects a circle in one spot, and a secant, which is a line that contains a chord. But because the vertex is on the circle, then we use the formula half of the arc. And once again, it's half of the intercepted arc, and the intercepted arc is arc AB. Okay, looking on this one, do you see how the angle is inside? So we're going to focus on inside. And if the angle is inside, we take half of the arc plus the arc. So if I want to figure out what angle X is, I need to figure out what half of this arc AB is plus this arc CD. And we're going to practice a bunch of these in a little bit. Okay, and then this one, you can see the angle is outside. And so if the angle is outside, we're going to use the formula half of arc minus arc. So if my angle is outside the circle, I'm going to take half of the biggest arc minus the little arc. So it's going to be the big arc minus the little arc. Okay, so let's just fill out these bottom 3 down below. It wants us to name all of the inscribed angles. Do you remember what an inscribed angle is? Its vertex is on the circle. Okay, I'm going to draw you one. This right here is an inscribed angle because its vertex is on the circle. How can I name that angle? Angle what?
OD.
ODG. Angle ODG. The other one you could have given me was GDO.
Or GOD.
No, GOD is a completely different angle. This angle that I colored in pink is angle ODG or angle GDO. Those are your...
Oh, you're talking about the angle. I thought you were talking about the whole overall thing.
No, I'm talking about the angle that I colored in pink. And so then it wants to know what its intercepted arc is. Because remember, if the angle is on the circle, if I want to find the measure of it, I take half of the intercepted arc. Do you know which one is its intercepted arc? OG. The intercepted arc would be OG. Can you guys stop talking back there? So if I have an angle that is on the circle, if I want to calculate what this angle is right here, I take half of the intercepted arc, and that's the intercepted arc. This is just trying to practice you knowing what your angle is and where its intercepted arc is. Okay, I'm going to draw you another one. This one I'm going to go in green. So what would this angle be right here that I just drew in green? GOD or DOG?
DOG.
So I don't care. DOG or GOD. Okay.
The GD?
And its intercepted arc would be GD.
Let me guess the next one.
So hang on a minute. So if I wanted to know the measure of this angle right here, since the angle is on the circle, it'd be half of the intercepted arc, which is DG. Okay, and then the other one, do I have another color?
Oh, wait.
Let me color it. Okay, this one I'm going to color in blue. And what would you say that angle is? OGD. Angle OGD or DGO. So angle OGD. And what is its intercepted arc? DO. So if I wanted to know what this angle was, I would take half of the intercepted arc, which is arc DO. Okay, so basically what we're going to do when we see our problems, we're going to figure out if the angle is on the circle, outside the circle, or inside the circle. If the angle is ever on the circle, like these two right here, we're going to take half of the arc. If the angle is inside the circle, we'll take half of the two arcs added together. And if the angle is outside the circle, we'll take half of the biggest arc minus the smallest arc. Okay? So let's look at some. Example 2. It says, given that the measure of arc BC is 100 degrees, find the value of x in circle O. Okay, so arc BC is 100 degrees. One thing I've noticed about a lot of these problems is if they give you pieces of the circle, you really need to start figuring out other pieces of the circle. Okay, and they want to know about angle x. So let's look at angle x. Colton, would you say that Colton C, would you say that this is an angle that's on the circle, outside, or inside? The vertex of the angle, I should have been more clear. The vertex of the angle, is it on the circle, inside, or outside? It's on the circle. So whenever our angle is on, the angle will be half of the intercepted arc. So whenever the angle is on the circle, the vertex is on the circle, we'll find this angle by taking half of the intercepted arc. Do you know which one the intercepted arc is?
A to B.
Uh-huh. So I need to know what that is.
Wouldn't that be 80?
It is 80.
Yeah.
Because this is a semicircle, right? And so if this is a semicircle, that's 180. And this piece, if it's 100, then this piece up here is 80. Okay, so x would be half of the intercepted arc, which is 80. And what is half of 80? 40. And that's what angle x is. So if the vertex of the angle is on the circle, it's going to be half the intercepted arc. Okay, example 3. It says find the value of x. So first of all, let me just draw my angle. Is the vertex of the angle on the circle, inside, or outside? On. Okay, the vertex of the circle is on. So because it's on, I'm going to find the angle by taking half of the arc. Okay, but this time I actually know the angle. What is the angle? 30. The angle is 30, and that's going to equal half of the arc. And the arc is what I actually want to know. How can I figure out what that arc is? Multiply by 2. And it would be 60. So we're going to actually do that several times today. So I'm just going to show you here. If I want to get rid of the 1/2, then I can multiply this side by 2, and I can multiply this side by 2. That way these 2's and 1's just cross out, and then I get that the arc is 60. And of course you probably could have just figured that out in your head. If this is half of the arc, then this is going to be 60, because 30 is half of that. Okay, let's look at the next picture. This angle that we have going on here, angle x, is it inside my circle, or outside, or on? Okay, so I'm going to write inside. And the formula on the other page was the angle is going to be half of the arc plus the arc. So these are the formulas that we'll want to get down on a foldable because it's just too much to memorize. So if the angle's inside, we're going to find the angle by taking half of the arc plus the arc. Okay, so x will equal half of the arc plus the arc. So our first intercepted arc is this guy. And how many degrees is that? 70 plus the other arc, which is 30. Take a second, figure that out. Miss Wood? Miss Wood? Good, how are you? Uh-huh. Okay. Uh-huh, bye. Okay, what'd you guys get? 50. Half of 100 and half of 100 is 50 degrees. Very good. Okay, and then example 5, the vertex of angle X, would you say that it is on the circle, inside, or outside? Okay, so I'm going to write outside. And whenever it's outside, the angle equals half of the big arc minus the little arc. And I know I'm not writing big minus little, but that's what it is. So if the vertex of the angle is outside, then that angle will equal half of the big arc minus the little arc. Okay, so X is going to equal half of the big arc. And so the big arc would be this piece minus the little piece, which is this piece. Do you know what that big arc is?
210.
How much?
210.
How do you know 210? Good. In a full circle, it should equal 360. So if we take 360 minus 150, then that makes 210. So this whole arc here is 210. So I take the big arc minus the little arc, and how much is the little one? 150. Okay, take a second and calculate that one for me. And what do you get? 30. Do I need to actually show my work? You're okay? Okay. Let's flip the page and just practice the formula for a little bit. So there's actually no work to do on these problems. We're just going to figure out what kind of angle it is, and then we're going to write down what the formula would be. So this is just to try to get it in your head. Okay, so we're going to figure out if the angle vertex is a central, in, on, or out. And then we're going to write down the formula that would apply. Okay, so looking at picture number 1, this angle that we see here, would you call it a central angle?
Yes.
In, on, or out? It is a central angle. We learned about that in the last packet. If the vertex of the angle is in the center of the circle, it's called a central angle. And then the angle, do you remember how we figured out what this angle equaled? The angle equaled whatever the arc is. Whatever this arc is, so let's say this arc is, sure, 60. If this arc is 60 degrees, then the angle would be 60 degrees. So that was from last unit. Last unit, we talked about a central angle has its vertex at the center of the circle, and that central angle equals exactly what the arc is. No half of anything. It's just whatever the arc is. Okay, number 2. Would you call the vertex of this a central angle, in, on, or out?
In.
The vertex of the circle is on, so I want to write a formula for the angle. If you need to flip back, look. Do you remember what the formula is when it's on, Mark?
Why is there 2 number 2s on here?
I don't know.
1/2 arc. No, arc. That's it.
It's just half of the arc. Okay, today is easier than yesterday, but that doesn't mean I want you talking. So if the vertex of the angle is on the circle, if I want to figure out what this angle is, it's half the arc. So let me just make something up real quick. If this arc is, say,
72.
okay, 72, I'll go with that. If this, which we really need to go bigger than that, but that's okay. If this whole arc was 72, what would this angle right here be?
36. That'd be 36.
Is it?
This is 1/2 arc.
It's 36. Yeah, it's 36.
Everybody agree? Okay. So that would be 36. Andrew, what was your question? Did you have a question?
Never mind. I was just wondering if instead of writing arc, you could put the little arcs on.
You could. Okay, number 5. Just practicing formulas for a little bit. The vertex of this angle, would you call it central, in, on, or out? It is out. So if I want to find the formula for the vertex when it's out, it's half of what?
The big arc minus little arc.
Yes, half of the big arc, and I'll go ahead and write that this time. Half of the big arc minus the little arc. So if the vertex of the angle is outside the circle, it's going to be half of the big minus the little. So this one would be the big, and this one right here would be the little. Okay, let's just go ahead and look at number 7. Number 7, would you say that the vertex of this angle is a central angle, in, on, or out? It's on. See the vertex? It's on the circle right there. So the formula would be the angle right here would equal half the arc. So when it's on, it's just half the arc. Okay. Number 9.
Out.
It is out. And so if I want the formula, the angle on the out would be good. Half a big arc minus little arc. Really, the whole point of this page is just for you to know your formulas. So it'd be half of the big one, and the big one would be, of course, this guy, minus the little one, and the little arc would be that guy. Okay, let's go ahead and flip the page. Let's look at 11. When I look at number 11, would you say that the angle is a central angle, in, on, or out? And I can see why you would think that it's central. And it is central. See how the vertex is at the center? So let me just call this little x right here. So it is central. And because it's central, the angle would equal, do you remember? The arc. Whatever the arc is, that's what the angle will be. So if this arc right here was, say, 40 degrees, what would x be? X would be 40. So if it's a central angle, if the vertex of the angle is at the center of the circle, it's called a central angle, and the angle equals exactly what the arc is. Okay, let's jump down to 19. I've been waiting to do one of these. So number 19, would you say that the angle is central, in, on, or out? It's in. Okay, so this is a different formula. We haven't written it on this page so far. Do you remember what the formula is?
1/2 arc.
1/2 of arc plus arc. So it would be 1/2 of this arc right here plus this arc right here. So 1/2 of this guy plus that guy. Okay, so how do you feel about just the formulas? Okay, we're going to skip to page 14. 14 practices more of this. We just have more equation kind of problems. Okay. So, example 11, I'm just going to color this angle right here. Would you say that the vertex is a central angle, it's in, on, or out? It's on. So if I want to find the formula, the angle would be, do you remember? Half the arc. So whenever the vertex is on the circle, then the angle will be half the arc. Okay, so do we know what the angle is? Okay, so the angle is 89, so it's going to be 89 equals, and then it's half the arc. So half, and then our arc is how much? It's half of the 11x plus 2. I could solve this different ways. I could actually take the half of the 11x plus 2 and get some decimals in there, but I want to get rid of the 1/2. How can I get rid of the 1/2? Multiply by 2. So if I multiply this left side by 2 and I multiply this right side by 2, then on the right side, the 2's and the 1's just cancel out, and all I'm left with is 11x plus 2. And then on the right side, I'm sorry, on the left side, how much is 2 times 89? 178, right? Okay, and then I just want to solve this equation for x. So what would I do from here?
Subtract 2 from one side.
Okay. Subtract 2. I'm not going to show it. What would you get?
176.
176, and then what would you do?
Divide by 11.
Divide by 11, and what would that answer be?
16.
16, and there it is. So it's applying the formula that we talked about a little bit ago. It's just you actually have an equation to work out. Colton, stop talking. Next picture. The vertex, would you say that it's a central angle in, on, or out? It's out. Okay, so I'm going to write out, and then I'm going to write down my formula. So when the angle is out, do you remember what it is? It's half of the big arc minus the little arc. So I'll go ahead and write big arc minus, how about little arc? So it's half of the big arc minus the little arc. Okay, so this would be the big arc right here, and this would be the little arc right here. Okay, do I know the angle? The angle is how much? So 40 equals 1/2, and then how much is the big arc? 150 minus the little arc, which is x. Okay, so I'm going to get rid of my 1/2, and this is how I'm going to do it every time, by multiplying by 2. So if I multiply the right side by 2 and I multiply the left side by 2, then the 2's and the 1's just cancel out. So all I'm left with is 150 minus x on the right. And on the left, what would you have?
80.
80. Okay, take a second and finish solving that for x.
Is it 70?
Did everybody get 70?
Yep.
Yeah, you would subtract the 150, which would make a negative 70 equals negative x, and if you divide by negative 1, that makes a positive 70. Good. Okay. This next one. So the vertex of this angle, is it a central angle, in, on, or out? It's out. Okay, so it's the same formula as last time. The angle will be half of the big arc minus the little arc. So half a big arc minus the little arc. And then I'm just going to start plugging in what I know. Do I know what the angle is? The angle is x plus 25. And then equals half of, okay, so the big arc is this guy right here. And those little dot, dot, dots, they go too far, so I'm sorry about that. So how much is that big arc? 4x plus 5. And then I need to subtract the little arc, and the little arc is 50. Okay, let's just go ahead and get rid of the 1/2. I'm going to clean up what's in the parentheses in just a second. How do I get rid of the 1/2 again?
Times 2.
Times by 2. And then when I multiply the left side by 2, I need to put parentheses around all of it and make sure I distribute that 2. So on the right side, the 2's and the 1's cancel out. What do you get when you distribute that 2?
2x plus 50.
So 2x plus 50. And then let's go ahead and clean up what's in the parentheses. On the right side, if I clean up what's in the parentheses, what would you have?
4x minus 45.
Good, 4x minus 45. Okay, finish that up, and then I'm going to draw a name. And you will get a decimal, yes.
Do we just round it?
48. Wait, do we just round it, or do we?
Well, the only time I worry about rounding is like if you have more than one number after a decimal.
So 47.5.
Okay, so I guess I won't draw a name. Okay, was everybody getting 47.5? Do you need me to actually work it? Okay, so 47.5. Okay, let's flip to page 16. How are you feeling about these formulas? Are you okay? Okay, so page 16 is more of what we were doing. Some of the problems are a little easier than the ones we were just doing. So I'm going to give you a two-part assignment. This page here actually has math involved. So on this page, you're going to do the ones that aren't crossed out. So this is going to be your homework. So you've got 1, 2, 3, 8, 9, 10, 11, and Well, I don't know why it's number 9, but number 9 down here. So you'll do the ones on this page that aren't crossed out. And then the other thing I was going to have you do was that page we were working on earlier that was just the formulas. And I was going to have you do the evens. So, earlier when we were on page 8 and page 9, and we were just writing if it was a central angle in, on, or out, and then writing the formula. So there's no math here. It's just naming what kind of angle it is and then giving me the formula. So on page 8 and 9, I wanted you to finish up your evens. That shouldn't take very long. And then on this page, I just want you to do, page 16, I want you to do the ones that aren't squiggled out. Okay? So you have a little time right now. I don't care which page you start with. This one, of course, is the harder one. So if you want to start with this one, you can. But if you want to start with the easier one, that's no big deal. So you've got the evens on page 8 and 9, and then page 16, except for the ones that are squiggled out.